Hey, F5 community, Aubrey here with DevCentral. I'm here to bring you another installation of our AI step-by-step labs that we've been working on here, and this one is going to be a pretty interesting one. We're going to be using multiple models in this particular flow. We will be using n8n to construct a piece of software that will utilize multiple AI agents to increase the efficiency of prompts that you might feed an AI construct. This will allow you to only use a real larger scale reasoning model when it's appropriate for the prompt that was issued. So the idea is pretty simple here, and it actually explains out a mixture of experts architecture for artificial intelligence because it has one specialized agent that has a model attached to it that is utilized to classify text for the incoming prompt, and then it will simply, its only function is to pass that prompt out to the most appropriate model that it has defined for itself. So the models that we will be using, or the agents rather, because it is going to go to a full-blown agent that has a model attached. So each of these can have advanced functionality as well. But we will do a reasoning agent, a coding agent, and a much more general agent that really will not cost you a whole lot. And the coding is highly efficient so that you're going to be able to, again, use as few tokens as possible and really keep the costs down for your infrastructure. Now, one thing that you should have done by now is our intro step-by-step labs. Namely, two that come to mind will be the Ollama installation and then the n8n, either of the n8ns, the n8n on Mac or the n8n that was for Docker, either one of those. But you should be familiar with how those are set up, and we are going to set them up in the exact same way in this lab to get us rolling really quickly for what we want to get done. Okay. I'm going to share my desktop and we will get rolling on this thing. And you've got to have Docker installed on something because we're going now. Actually, Docker installed on everything. The lab really expects you to have one machine for models and another machine for applications, right? So we will have n8n running on the app server, and we're going to have Ollama with some downloaded models anyways, not customized. You could customize them if you want, but we are going to have some downloaded models in Ollama running on our model server. Okay, so the first thing that we're going to do is we are going to configure our LLM host to utilize the NVIDIA hardware that we've got. Perfect. And we restarted our Docker daemon, so that should be done as well. Next, we're going to create a Docker volume for our model data so that it can persist if we end up crashing or end up getting disconnected from our model server while this is going on. Now, the next thing we're going to do is we are going to bring in Ollama. That is the real star of the party. So here's a Docker run, and that is going to call on my model data that I just defined in the interface as well. We're naming this container Ollama just because it's very simple. Now, if you do get disconnected from this after, or if you have to come back to the lab for any reason, all you have to do is do a Docker run Ollama, and you'll be back to where you were. After this, we are going to install several models that we'll be using throughout the building process here. So most of this is going to be variants of DeepSeek and Llama. So we will be using, if anyone is familiar with these, we're going to be using the infamous DeepSeek R1. This is a Docker exec Ollama pull, and then the DeepSeek version, which is R1, the 1.5 billion model first. The other DeepSeek model that we will be using is R1 7 billion. Next, we're going to move on to Llama 3.2. And lastly, we are going to pull CodeLlama, which is highly refined version of Llama that is explicitly for things like Python, JSON, Node.js, iRules, right? That's the kind of thing that we really want to utilize CodeLlama for. Okay, so now that that is done, we've pulled the images that we want to pull. And at this point, we can run our Docker container to install n8n on our application server. So the first thing that we're going to do is create, similarly like we did with Ollama, we're going to create an n8n data volume so that we can have saved n8n flows even if we have to shut the lab down. That's something that's definitely going to be necessary. So I just created my n8n data, and after that, I can go ahead and pull the latest Docker container for n8n. All right, it's coming down, and that will take a little bit of time. Now, typically after this, you are going to want to open the n8n interface or the n8n UI, web UI, which would exist on whatever your app server's IP address is, or localhost if you are doing this on your local host. But you're going to have to point a browser at that to port 5678. So if your IP address was like mine, 10.1.1.4, you'd enter in https://10.1.1.4 colon 5678. So we want to make sure that we utilize n8n's custom port for making things easy. Now, in my situation, I have a web proxy set up in this lab environment. So I am going to open my interface in a separate tab, which has a little bit of a different sort of URL there. All right. So when you get to your browser, port 5678, you are going to see this interface, and we have to set up an owner. So for me, I'm going to put an address in there. You have to put in a valid email address here because they're going to ship you a license key to that same email address, and you will need to paste that into this environment. So I'm going to say your email at somemail.com. First name, Aubrey. Last name, King. And the password is going to be super secret or whatever you choose to make it. And then we hit next. So this customization screen comes up. It's a little bit of just questions about your company and your job and things like that. You don't need to do that. Just go ahead and get started. And right here is where you would have it send you your free license key to your, again, valid email address that you input. So I'm going to skip that for right now because I already have mine mailed to me. So once yours is mailed to you, I want you to go ahead and click down in the lower left-hand corner here, where you will go to settings, and you can actually enter your activation key here. I'm going to take a second and go grab mine. All right, I'm going to go ahead and paste that in. I've activated, and I now have a registered community edition that is up and functional. Okay, now we get to do the fun stuff. This is where the action really gets started. Okay, so we need to get out of the settings. That's the first thing, and go back to what is called the canvas for n8n. That is where you're going to develop any of your workflows that you want to use with artificial intelligence or without. You don't have to use AI in n8n, but where's the fun in that? So we're going to start from scratch here on this one. And the first thing we want to do is make sure we add a trigger for this. So we're going to be using a chat message because the sort of application would be, if you can imagine, having this chatbot join a Slack channel or something like that, ready and waiting for incoming prompts from a team of engineers. That sort of thing is what we're more looking for. So once we've got this defined, I'm going to head back to the canvas and open my chat where I'm going to actually send a chat message. Why do I do that? So that I have test data to work with as I go down my chain. It will allow you to actually test out your program as you develop it if you just enter a chat message out of the gates. So I'm going to say which language is better. C++ or Java. And when I hit enter, my node has been executed successfully. You can see that I got a chat input. That was that's what I made. I made a chat input for use with some other node here in n8n. Okay, so I scrolled over just a little bit so I can have some room. And first thing I'm going to do is hit the plus button here on my chat message received, which pops up this window. And I want to find a text classifier. So one of the things I'm going to do rather than going into all these menus is I'm going to use the search. I know text, right? So text classifier is what I want to do. Now, if you have text that you want to classify, right? I did my chat message, which was which language is better, C++ or Java. And we can see that here. That is an element of the input passed into this node right here. So if I want to make sure that I have the chat input, and we can look at this in JSON as well. So you can see if JSON is more, your forte rather than looking at a raw schema. This chat input segment here is exactly what we want to pull. So we're going to drag this over into class or text to classify. And look at that. It will even output the result of what that is for my test. So text to classify is JSON.chat input. And the result is which language is better, C++ or Java. Fantastic. We need categories, though, for our classification, right? We want to make sure that we have reasoning category. And we're going to put in a message. So the description for reasoning would be if reasoning need is indicated by the chat message, this is the category to assign. Very simple. Then the next one, we're going to add another category. This is going to be called coding. And similarly, we will have if the chat message indicates a need to code or asks for help with computer languages and scripting languages like iRules, JSON, or Node.js, assign this category. We'll paste that description right in here as well. Now, there are a couple other options we need to set because that gives us two potential answers. But what if our question is neither of those? Like, hey, are the Philadelphia Eagles a good football team? Well, we need a more generalist node that's going to take care of that because a coding node won't have any idea what to get. It'll give you a piece of code to try and answer that. And the reasoning, it could classify as a reasoning, but how do you make a sandwich would be another good example. So we need to go ahead and do a couple things here down in the options. First thing, when no clear match, if we don't match our two categories, what are we going to do? We don't want to discard this item. We want to output on an extra other branch. That sounds exactly like what we want to get done. In addition to that, we also want to make sure that we have a system prompt. So a system prompt will be critical for our application to work because this is going to be a highly specialized node, and we want to make sure that it knows that it needs to just answer some very, very specific things and do it very quickly. So we are going to I'm going to paste in a system prompt that I already designed and read it to you. This one is working like a champ for me. So what it says is, please classify the text provided by the user into one of the following categories. And then it allows for a category string. So we can dynamically change our system prompt per call. Every time we add a category, we're going to be allowed to expand or contract that list. As long as there's, some categories in there, it will obey this system prompt. And use the provided formatting instructions below. Now, the formatting instructions are pretty simple. If they explicitly ask for coding help, do not fail and classify the message as coding. After that, we want to ask if they explicitly ask for reasoning help, do not fail and classify the message as reasoning. Otherwise, send the JSON chat input. That's exactly what we wanted to put, right? We had a chat input defined in our JSON input for this node. So we want to send that guy back on to the next agent. And we do not want multiple cases to be true. So took that out. Now, if I'm in here and I want to test this right now, up at the top, I can actually execute this step immediately. And there's a problem. A submodel must be connected. So I guess let's do that. If we head back out to the canvas, we could have done that in the text classifier at the very bottom as well. There's a plus sign there, but typically what I like to do is make sure that I'm doing this the same way every time. And so I'm going to add plus sign here where it says model under the text classifier. And again, we're going to search our nodes for Llama. Okay, Ollama model. Now, we don't have any credentials, but we did set up Ollama on the 10.1.1.5. So let's add new credentials. We're going to create new credentials for that. We also have to make sure that we're not on localhost, but we're pointing to an IP address, 10.1.1.5. Port 11434 is what Ollama runs on. So I've defined that now, and I'm going to save it, which will also test my connection. And voila, I have nice green screen here to say that the connection has been tested successfully. I'm also saved, and I'm going to close out of this window. Now, what model would I want attached to my classifier, my text classifier? For me, I wanted something that was reasoning, because we're sometimes going to have weird prompts that come into this thing, and we're going to need to sort of deeply understand some of these things at times. That said, I didn't want to use the full smarts, our 7 billion parameters model. So I am going to go ahead with DeepSeek R1 1.5 billion and add that as my model. Now that I've done that, I can go ahead and go back to my canvas, and I can retest this text classifier. Let's go ahead and execute that step. And it will take a minute because we're dealing with a large language model here. Now, with this one, you see that I actually failed when I executed the step. That's because we have a couple of settings that we need to make sure that we have set. We want to retry on fail for certain, and we can try 3 times. Now, the reason that we want to do that is more specific to my environment, but it could happen with your environment as well. If you're in any situation where you might have an issue maintaining a long-standing connection with your server, or it's a cloud node, that kind of thing. Mine happens to be in the cloud, which is what I'm having an issue with. So I find that if I increase the max tries here, if I leave the default max tries at 3, this ends up working pretty well. We're going to head back to our canvas for now and set up the rest of this thing and come back to the testing as soon as we can. You will see that the Ollama model was in fact used, which is kind of nice. But we do need to put some of these other pieces to the puzzle in place before we're going to get success here. So let's go ahead and add a reasoning agent. Okay. So if I look for agent, and I have an AI agent, I'm going to first of all name this guy reasoning agent. Because when you have a more complex flow, it's much easier to name your objects rather than leaving them at the defaults. Now, this agent is going to be pretty basic here. We are going to set a couple of settings, though. Similar to our last node, we're going to want to retry and fail with 3 tries. And we need to add a chat model, which I can do at the bottom here, as I mentioned prior. So we are going to stick with Ollama and use our same Ollama account because we're using the same server. And for this reasoning model, we want to make sure that we use the real smarts. This is where you want to say, okay, I've already had one model say, yeah, this is where we will need some intelligence. So we'll use the 7 billion parameters, and we are going to go back to our canvas now that that's all set. I like to move these around a little bit just so they're not in the way, and I'm going to zoom out a little bit here so that I can make room in my canvas for some of this stuff. Okay, now that we're finished setting up our reasoning agent, we're going to try our coding agent. And again, we're going to search for agent And we are going to go to the settings, retry on fail with the same max tries of 3. The chat model is going to be, again, Ollama, but this time, since we're going to be using coding, we want to use CodeLlama and the latest. Now, also, one thing that I didn't do there was rename my agent, so I am going to do this another way to rename it. I can right-click on this and select rename. So this will be coding agent. And we're going to rename that. So we do have our Ollama chat model connected. And now we want our fallback other agent. We're going to use an agent again. And the settings will again be retry and fail. The chat model that we're going to plug in here, though, is going to be, I would urge you to go with DeepSeek R1, the 1.5 billion parameters, or you can use Llama 3.2 because both of those are decent general agents. I'm going to go ahead and utilize DeepSeek 1.5 billion, the R1 variety. All right, so now we are back to our full built lab here, and we're ready to test this thing. So we've actually already sent one test message in to try and build with, but let's see if this works. I'm going to go ahead and say, I need help writing a program. I'm going to say coding because you want to make sure that it has the best data possible. So if it's looking for coding, probably better to say coding. I need help coding an application written in Python. Could you please provide a snippet of code that will post pictures to LinkedIn? Please. And hit go. At this point, you can see that the flow is executed. My chat message goes into my text classifier, which is working with DeepSeek R1 1.5 billion right now. And we will go ahead and select a model to send on my prompt. You can see here that we have selected the coding agent. And right now we're going through CodeLlama to make sure that we have an appropriate answer to my question. And we see that the node executed successfully and returned code to me. So if I look in my chat interface here on the lower left, I do have a snippet all set. Now, I am not going to speak to the validity of the snippet. I have found a little bit of hit or miss. I will be honest with that. But I think that the idea here is still pretty sound. This is going to get better over time. And of course, if you're not working with free models, you tend to have some different experiences. When you go ahead and can plug something like Claude into this construct or ChatGPT, or if you have the hardware to run the higher end DeepSeek models, that kind of thing, you're going to be able to do quite a bit more with this sort of flow. Anyways, once you've reached this point, I'd encourage you to go ahead and chat with the construct. Try and ask it some interesting things like who should you vote for in the next election or something like that, and let it know what you're weighing with. What I find is that oftentimes it will select a reasoning model if you ask it to help you decide on something and to give a recommendation. Now, general questions as well. The ones that I like to use are, how do I make this sandwich or whatnot? Very simple stuff that it can go ahead and respond with. Now, the other thing would be there are the utilities within here to actually bind this sort of construct to Slack. So it would be an interesting exercise to go through and actually find out how you would do that. So where you go from here on this one is kind of up to you. I love that it's sort of open-ended. but we are working with non-deterministic technology here. So your mileage is always going to vary with this kind of thing. Um, the question is, can we make it where it doesn't vary that much? So the tuning of these applications via system prompts and via some of the other utilities that we had here insofar as retries are concerned, or always outputting data somehow. There were, as I was building this, I was able to, or I was experiencing some problems where the text classifier, due to the model that I was using, would go ahead and spit out some unknown stuff. It would fail and say, I can't classify this thing, but I have some ideas. So I told it to always pick something no matter what. And it started picking, and I said it could pick multiple models if it wanted to. So it picked a couple of different models and would send them both the prompt. Some of the answers I got were pretty amazing. So give it a shot and let us know what you come up with in the comments. All right, well, that's just about going to wrap us up for the day. Once again, thank you so much for joining me, community. I'm Aubrey with DevCentral, and this has been another installation of our AI step-by-step lab. I hope to see you at the next one.